All right, 57 through the end, odd. We did not get to these in the second period, so posting them now, talking to an empty class. But you're watching, so good for you. Number 57. Which of the following equations has a horizontal asymptote of y equals 3? Okay, a horizontal asymptote, that happens as x goes to infinity. So this is the sneaky way of asking for a limit as x goes to infinity. And as x goes to infinity, that's when we get to use the top no, bottom O, equal co shortcut. And if we want an answer of 3, the only way we're going to get an answer of 3 is if we have equal co equaling 3. So let's see here. Roman numeral 1. There's our most important terms. It is an equal co situation, but the co is negative 3. I probably shouldn't put equal there. The limit equals negative 3. So that's a no. This one would not even be an equal co situation. It would be a, let's see, 3x squared over x becomes 3x, so that's headed to infinity, so that's a no. This one we've got a equal co situation, and it equals 3. The coefficients equal 3. So the limit goes to 3, which means the horizontal asymptote is 3. So that's the one we're looking for. 59. Limit as x approaches 4 of that thing. That's pretty clearly 0 over 0 to start with. So let's factor difference of cubes. Hopefully you've done enough of these that you remember SOAP for the signs. Same, opposite, always positive. Square the first one, multiply the two together, square the second one. Sure enough, the x minus 4's cancel. That's good. And then we can try again with plugging 4 in for x. So we got 1 over 16 plus 16 plus 16, which should be 1 over 48. All right, 61. The graph of that thing has infinite discontinuity. That would be a vertical asymptote. Removable discontinuity would be a hole. So it definitely can't be both of those. Horizontal asymptote, that's limit as x goes to infinity. And vertical asymptote is the same thing as infinite discontinuity. So I think A and D are out just because that's the same thing. Let's work it the right way and see what we learn here. X times x squared plus x minus 6. So x plus 3 and x minus 2. And then in the bottom we've got x plus 2 and x minus 2. So the x minus 2's cancel. That means there's a hole at x equals 2, which is B, so I'm pretty sure it's B. There's a vertical asymptote at x equals negative 2, not at 2. Again, A and D are saying the same thing. And the infinite limit, well, the x cubed is bigger than the x squared, so the limit as x goes to infinity would be infinity, so there is no horizontal asymptote. So yeah, it was B. 63. F is a continuous function on the closed interval. F of A is less than f of B. Which of the following must be true? Oh man, there's a lot of... Okay, I like to draw what it tells me. So it's continuous from A to B. F of A is less than f of B, so there's my endpoints. It's continuous, so there's no jumps, no holes, no asymptotes between there. Might be going up and down, so I don't really know how we get there. Let's see what we... There exists a number C between A and B. Okay, so all of those are the same thing, or at least they start the same. So there's definitely some C in between A and B, such that f of C is between A and B. F of C is the y value, A and B are x values, so that doesn't really make sense. That's out. F of C is between f of A and f of B. F of C, so wherever f of C is, I'm not sure that that's true. Such that f of A is less than f of C is less than f of B. I don't think that's true. Because if this thing went up and peaked at C, then f of C is bigger than both of those. So I don't think that, I don't like B. Answer C. There exists a number such that C is between f of A and f of B. Again, this looks funny because this is C is x values and A and B, f of A and f of B are y values. So that doesn't, that's like for the same reason A is out, C is out. Question D, there exists a number C such that f of C is greater than or equal to f of B. F of C is greater than or equal to f of B. Maybe, but maybe not. Like, oh, or equal to. No? Yeah, it could be like that, and then f of C is less than f of B. So I just threw them all out. Interesting. Back to B, because that's one I wasn't sure about. F of C is between f of A and f of B. I still don't think that has to be true. Continuous. F of A is less than f of B. Yeah, I don't think this has to be true. Must be true. F of C. I don't like this question. I'm going to check with a few people on that one. I don't like that one. There's not one like that on the test. Worry not. 65, and final. Given f and g is a continuous function h that has the property that h is between f and g. Okay, this looks like maybe intermediate value, but it's also it looks more like squeeze theorem. Intermediate value is more about values. When they're functions, it looks like h is going to be squeezed in between f and g. What is the value of the limit as x approaches 0? Okay, as x approaches 0 for h, I can't plug it into h because I don't know what h is, but I could plug it into f and g, and if f and g are equal to each other, then we have the sandwich theorem, the squeeze theorem. So let's try the limit as x approaches 0 of f of x. So all I have to do is plug in 0. Cosine of 0 is 1. And then for g, we'll plug in 0. 0 squared plus 1 is 1. So the limit of f is 1, the limit of g is 1, and h has to be squeezed in between there. So for the only way for that to work would be for the limit as x approaches 0 for h of x to be 1. Like it's just got squeezed or sandwiched in between there. There's nowhere else for it to go. It's got to be 1. All right, hope that was helpful. Press like and subscribe to make sure you don't miss the next video. And I feel like I'm putting out more videos than Mr. Beast today. So thanks for watching this long. Good luck on the test.